So here we're going to talk about three more properties of triangles. The first one is the angle-side relationship, which basically says that the longest side is across from the largest angle in a triangle, and the largest angle is across from the longest side. So I'm just going to play with this app to show that relationship. Actually, it's true about all three sides. The shortest side, a really short side, will be opposite a small angle. This narrow angle just shows that narrow slice, whereas a large angle, like 149 degrees in a triangle, that will generate a very big side across from it, because that opening has to open up to make that side that's across from it. If that angle becomes more narrow, then that side becomes shorter relative to the other two sides. So that generates two kind of particular triangles, more than just two, but these are two that I just want to point out. An isosceles triangle is when we have two angles that are the same, creating two legs that are the same. Actually, that's going to be our next theorem that we talk about. But we have a base and then two legs that create a vertex angle, and those are our base angles. So the base angles are directly across from the congruent legs, where in an equilateral triangle, all the angles are the same, so it's equiangular also, making all of these sides the same. So it's just pointing out the relationship between opposite sides and their angle. The base angles theorem specifically talks about isosceles triangles. So if two sides of a triangle are congruent, that's our given statement in the base angle theorem, that the sides are congruent. Then we can jump to the conclusion that the angles are also congruent. The converse of that is just going the opposite direction. The two angles are congruent, then we can jump to the conclusion that those two sides are also congruent. The last property we're going to talk about is the triangle inequality theorem. So that basically just says that any two sides that you add up their lengths, it will be greater than the third length. The sum of the lengths of any two sides of the triangle must be greater than the length of the third side. So that's really easy to see why. If you were to swing this either direction, like this picture is showing, if they are not bigger than this third side, no matter how much you swing those back and forth, you'll never actually have those connect somewhere in here. They can't possibly form a triangle if they're not greater than the third side. And that needs to work with all sides. Adding up these two sides should also be greater than that third side there. I think this is another good picture. If they were equal, the best we could do is lay those down flat and have it be equal to C, where that wouldn't actually form a triangle. If they're approximately equal, then we get this narrow triangle, and then once you start getting it greater, this is really also greater, but it's approximately equal. It's just very slimly greater. So I'm going to show how that can be applied to one of these questions, and then I'm going to let you try 2 and 3 on your own. So we want to figure out the possible lengths of this third side given these two sides. So we know that these two sides, if I were to put these two together, that side and that side, they would have to be greater than the third side. That's what the triangle inequality theorem really says. So really, x has to be greater than 4. If I subtract 8 on both sides of that inequality, it just tells me that x is bigger than 4. But this is not really drawn to scale, so don't let your eyes deceive you here. We could also be adding this one and this one together to get this side. So if these need to really be greater than that, not equal to it, if it needs to be greater than that third side, any two sides added up, this side and this side added up, would be greater than that. We're also finding that, actually I'm going to flip this around, x is less than 20. So x is greater than 4 and x is less than 20. So x is really in between 4 and 20. As a compound inequality, I'm actually going to flip this one around too. Basically, it's sandwiched in between those two possible values.